Hey guys, today we're talking about interval and set builder notation. Now, interval and set builder notation are just ways that we can write our answer whenever x doesn't just equal a specific number. Whenever x equals a range of numbers, especially in inequalities. Whenever I have something like x is less than 2, we need ways to show that, or when x spans a range of numbers. Now, set builder notation is just having an inequality, but it's like a little fancier, okay? So like take an instance, take a look here. X is less than b, that's just an inequality. But this is set builder notation. So we have these extra levels to it. With my squiggle brackets, those just really mean all the numbers of, everything that's in there, all the numbers of x. And this straight up and down line means such that. So when we read this, it's going to be all the numbers of x such that x is less than b, or whatever number we have in place of b. Now, in this, we can have multiple inequalities. Like I can have x is less than or equal to a, or x is greater than b. So we can have, like on my graph, x is less than or equal to a, so we have that filled in circle, and it's less than, so it's going to the left. Or x is greater than b. Well, it's not equal to b on this one, so it's an open circle, and it's going to go to the right. So this is just all the numbers of x such that x is less than or equal to a, or x is greater than b. The same thing goes for this one. All the numbers of x such that x does not equal a. So that this graph shows everything except for poor lonely a there. Okay, the other way that we can show it is through interval notation. Now, interval notation is really easy to write. All you're doing is writing the farthest left interval and the farthest right interval. And we use a bracket to tell if it's equal to that number, and we use a parentheses to tell if it's not equal to that number as well. So for instance, this x is greater than or equal to a. We use a bracket here around a to show that it could also be equal to a. So we go all the numbers from a to infinity, including a. So that gives me a closed-in circle, and then we fill off to the right. But when it's just greater than and it's not equal to, that's where we use a parentheses. And so we have a open circle as it goes off to the right. The same is true for the other directions. Whenever it is equal to, it is a bracket and a closed circle. And whenever it's just less than, we use a bracket and an open circle. Okay, you'll also notice this symbol here. It means infinity, right? We have negative infinity and positive infinity. So the filled in part is wherever my x is, wherever we're showing that my answer is. Well, sometimes it goes all the way down because it's everything less than or everything greater than. So we use negative infinity for everything to the left. We use positive infinity for everything to the right. And you'll notice that we always use a parentheses at the infinity points because we can't actually know exactly what infinity is. It's just something that we can get closer and closer and closer to. Okay? Last but not least, sometimes we have what's called bounded intervals. Now all that means is we have end caps. We have a cap on this side and we have a cap on this side. Okay? So if we have like x in between two numbers, x is greater than or equal to a, and x is less than or equal to b, then for interval notation, we have a cap on this side, a cap on this side, and you'll notice that these are brackets because it is also equal to. And we have these filled in circles, and we fill in everything in between. Okay? Whenever we have parentheses, we have open circles. Okay? And if 1 is equal to and 1 is less than, or not equal to, then we have parentheses on one side, brackets on the other, and we have a closed-in circle and an open circle. All right? So this is just ways that we can represent our answer to an inequality. And so we're going to be solving inequalities over the next couple days, but we have to first learn how to write our answer. So let's take some practice time writing our answer. Let's take a look here at number 1. So number 1, I have negative 2 is less than or equal to x, and x is less than or equal to 3. Okay, so I'm going to give you a tip here. It's always easier to read from x, to think about where x is. Okay, so in this case, x, hey look, x is bigger than or equal to negative 2, and x is less than or equal to 3. So whenever we make our graph, it's going to be pretty easy. I'm just going to draw my number line, and then I'm going to put a point at negative 2, and I'm going to put a point at positive 3. Okay, this first point at negative 2, x is greater than or equal to negative 2. So am I going to put an open circle or a closed circle at negative 2 for this graph? Good, yeah, I'm going to put a closed circle because it is also equal to negative 2. Now, the 3 here, I'm also going to put a closed circle on because it is equal to that as well. And I'm going to graph out to the right from negative 2 because it's bigger than negative 2, and I'm going to graph out to the left from 3 because it's less than 3. And you can see where it just meets in the middle there. All right, let's figure out the other ways. The next way that we want to write is inequality notation. Now, it's already in inequality notation, so we're good. Next, interval notation. So remember, interval notation is with the brackets or parentheses, and you're just laying out your parameters. So for this case, our parameters, we have a parameter on this side at negative 2, and we have a parameter, an endpoint on this side at 3. Okay? Now, am I going to use brackets or parentheses for this interval notation? I'm going to use brackets because it's equal to negative 2 and it's equal to 3. So there's my interval notation for this one. What about set builder notation? Well, for set builder notation, the great thing is set builder notation is just exactly like the inequality. It's just a little bit fancier, right? We just have the squiggle brackets. It's like I like to call them squiggle brackets x such that then we just write the inequality. Negative 2 is less than or equal to x, and x is less than or equal to 3, and then we're going to close it off with another squiggle bracket. So we've taken care of set builder notation right there. So we got set builder notation, we've got our graph, we have our interval notation, we have our inequality, and now let's talk about our verbal description. This is where you just explain it, right? I'm just going to write all numbers. It's always good to start off with that. All numbers, it's a good way to get started with your verbal description. All numbers between and including negative 2 and 3. That makes sense? All numbers between and including negative 2 and 3. I think that's a good verbal description. Let's move on here to number 2. Number 2, we have x is greater than negative 1. So once again, it gives us the inequality notation. So let's go ahead and make our graph. So we're just going to draw a number line. And we're going to say x is greater than negative 1. So I'm going to put a point here at negative 1. And am I going to circle that point at negative 1, or am I going to fill it in? Yeah, I'm going to circle that point at negative 1. All right, another question. Is my graph going to go to the right or to the left? Yeah, it's going to go to the right. And so just think about it. We're thinking about all the numbers that are bigger than negative 1. Wherever my graph goes, it's bigger than negative 1. And so think about which side is bigger than negative 1. Another way to think about it is this. If x is on the left side, whatever direction that arrow is pointing is the direction it's going to go. Be careful though, if x is on the right side, it's the opposite. But if x is on the left side, whatever direction that arrow points is the direction we're going to go. All right, so I have my graph. Let me do my interval notation real quick. Remember on this one, we're going to use parentheses. So I have parentheses -1 to positive infinity. I'm going to go -1 to infinity. Next, let's write my set builder notation. So set builder notation, once again, it's my fancy one, so I'm going to go squiggle brackets, x such that, and then we just rewrite the inequality, whatever the inequality was. X is greater than -1. Okay? All right, number 3. So number 3, oh, oops, I messed up. All right, we got to give our verbal description. Hey, this one's really easy. Remember what I said. Start everything off with just all numbers. Well, how can we describe this one? All numbers, I think it's pretty easy. All numbers bigger than -1. All numbers bigger than -1. There's our verbal description. Okay, number 3. It gives us a graph, but it does not give us anything else. So I'm going to go ahead and I'm going to think about my inequality first. Okay? So I'm thinking about where is x? Okay, so there's my x, and x is the line that's in the middle, right? All right, so x is bigger than this end, and x is bigger than -3. But does x also equal -3? Yes. How do I know that? Because it is filled in. All right, what about the other side? X is everything smaller than 4. But is x equal to 4? Afraid not. So it's not going to have the equal sign because of that open circle. Now that I have the inequality, I can also write it in set notation. So I'm going to write my squiggle brackets, x such that x is greater than or equal to -3 and x is less than 4. Okay? All right. And now for my interval notation. We're going to have a bracket on this side, on the left side, and a parentheses on the right side. The bracket on the left side because it's filled in, a parentheses on the left side because it's open. All right, and so my number on this side is going to be a -3, and we're going to go comma 4. And last but not least, my verbal description. This one might take a bit because we're going to say all numbers. We're going to start off just like that as usual. All numbers between -3 and 4, including -3. And we got to put that because there's that circle that's also filling in there. All right, number 4. Look where this arrow goes. It goes all the way from -infinity to 3. And it stops there at 3. So I'm going to go ahead and start with my interval notation. We can go in any order we want. I'm going to go parentheses -infinity to 3. Am I going to have a bracket or a parentheses on the end of this? Yeah, I'm going to have a bracket because it's equal to. So we have -infinity to 3. To write that as an inequality, it's going to be x is less than or equal to 3. Okay? You do not have to write the infinity on an inequality. In fact, you probably shouldn't. It's really frowned upon. Okay? So it's x is less than or equal to 3. All right, and then we can just write that in set notation. Squiggle bracket x such that x is less than or equal to 3. Okay, last thing, verbal description. As always, we're just going to start off with all numbers less than and equal to 3. All right, we only have a couple more. These are some important ones. You'll notice 2 things here. First, this one has 2 separate inequalities in that set notation. and it has this or in the middle. So I'm going to go ahead, let's draw the graph out for this one. That might help us picture it the best. So if I draw my graph out for this one, I'm going to go ahead and put a point at each of my numbers. So I'm going to put a point at 0, and I'm going to put a point at 4. My point at 0 is going to be filled in because it is also equal to 0. And my graph is going to be going to the left. Now, this one is going to be going open because it is just greater than and not equal to, and it's going to go to the right because it's greater than. Now, you'll notice they don't intersect. They're going in opposite directions. That's okay. This or was kind of a giveaway that that was going to happen no matter what. All right? So let me show you how to write this in interval notation. It's kind of tricky. So for interval notation, we're going to look at my graph here. We're going to start off with negative infinity because it's going to go to the left infinite amount of times. All the way to 0, and we're going to put a bracket there at 0 because it's equal to. Now, I'm going to use this fancy symbol. It's just a U, but it just means union. In other words, it just means or, okay? So, we're just putting these two together, and we use a U to connect it. So we're just going to have this interval and a U to connect it. And then we have a circle here at 4. It's going to go to the right. So I'm going to use a parentheses 4, comma, infinity. Now I use the parentheses because it is an open circle because it is just greater than and it's not equal to. Alright, and since I have my interval notation, I can write it as an inequality really easily. I can just go x is less than or equal to 0, x is greater than 4. So the only thing that I have left to do now is the verbal description. And all I'm going to say is all numbers except from 0 to 4. Let me clear that up a little bit. So it's from 0, and instead of just saying to 4, I'm going to say up to 4. So I can say it doesn't hit 4, it just goes all the way up to 4. All right. Last one, we also have that union symbol. It's negative infinity to negative 1, union, negative 1, positive infinity. And you'll notice that neither one of those are brackets, so it's not equal to that. So if I put this on a number line, it's going to look something like this. I'm going to have that point at negative 1. I know it's not going to be equal to negative 1 because of the parentheses, but it's everything less than negative 1, everything greater than negative 1. So in other words, negative 1 is the only one that doesn't count. So to write this as inequality, I can just write x. I can write x does not equal negative 1. And I can also write that in interval notation, x such that x cannot equal negative 1. Could I have written out the long way of everything less than negative 1, everything greater than negative 1? Yes. But why do that whenever I can just do it so simply here? And last but not least, let's do our verbal description. I'm just going to write all numbers except negative 1. All right, guys, that's our lesson for today. Please let me know if you have any questions. I hope you have a great rest of your day. Thanks, guys.